In topic 8.10, we are talking about the concept of LD-50. That stands for lethal dose 50%. And the LD-50 is a number that is used to quantify the risk of exposure to a certain toxin or chemical for a given organism. It basically indicates how toxic a substance is. And the definition, it's the dose of a chemical that's lethal to 50% of the population of that species. And so a lower LD-50 level means that a substance is more toxic because it takes less of that substance to kill 50% of the population. And so, for example, when we look at this chart on the right, we see a whole bunch of different substances. Okay, it lists where they might be found. Let's look at vanilla. Okay, this is a substance that's found in vanilla beans. It has an LD-50 of 1,600 milligrams per kilogram. And the quantification here is it would take 1,600 milligrams of vanillin for each kilogram of body weight, of mass for an organism to kill 50% of the population. And so we can look at these numbers, and we could look at, high LD-50 numbers mean it's non-toxic or lower toxicity, whereas lower numbers are very toxic. So the most toxic substance here on this list is botulism toxin, which takes only 0.001 milligrams per kilogram of body weight to kill 50% of an organism. And so I think these are for mice. So different organisms have different levels of ability to tolerate toxins. We see some of that here. This chart on the left shows the LD-50 for sodium fluoroacetate. Sodium fluoroacetate is used as sometimes a rat poison. And so we can see the LD-50 data here. So it takes about 1.2 for rats, if that's the purpose of using this substance. It takes about 1.2 milligrams for every kilogram of mass of rats to kill 50% of the population. And so this is important because, for example, if you're using the substance, the sodium fluoroacetate, around your house or around a property, what you can see from this chart is that, well, the LD-50 for dogs of this poison is much, much lower than it is for rats. So if a dog were to ingest this rat poison, again, it would take much less of it to be deadly to the dog than it would for the rats, 0.07 milligrams per kilogram. And so that's how we use this data, how we could use this data.